Recording here. Okay, this topic is very hard and it is completely advanced here. Okay, so we'll try to complete it. Let's see if you are able to grasp it. So cryptography means you will be modifying the information, or you will be hashing the information. Means you will be doing some algorithms before sharing any of the information. That is your cryptography basics. Okay, so agenda for the applied cryptography is you will be using the password hashing. Then you have here bcrypt. These are all the algorithms that you will be using it here. Okay, so there is one more called as quantum threat here. Okay, quantum threat means, so if you get any quantum computer here in near future, if there is a quantum computer commercial, so all the encryption will be broken. Okay, it will break the complete encryption, so that all the encryption standards will be taken off. Even the Bitcoin will also crash. So that is why they are having the quantum threat. Okay, then you have some post quantum cryptography. Okay, if you quantum computer also, if it is coming, so how to handle that post quantum cryptography. So those are the things that we will be looking at in this chapter here. Okay, so that is the agenda. Let's see here. So why you required password hashing is, so 8 billion passwords records are breached. Okay, so I have given you that link also where you can check the password. If your password is stolen or if it is compromised, you can see that in the link. Like you can log in into that site and you can see that I have shared you earlier. So you can go and check your username. My username appears in 25 sites there. Okay, so how it is breach means via the weak password or stolen password. Okay, so MD5 crack time is 1 second, less than 1 second. You can put 8 characters. Okay, so if your password is just of 8 character, it will be broken in 5 seconds, less than 1 second. Okay, so this also we have seen it, how much time it will take for 9 characters, 10 characters, 11 and 12, 13 characters. Okay, so that is why we will be mixing up the characters here. Okay, so then we have something called hashing versus encryption. Okay, so all the passwords will be hashed, okay, one way. So hash will be you will just get one time, that's it. Okay, encryption means you can reverse that. Okay, so even the server must not be able to recover the plain text. Okay, that is the difference between hashing and encryption. So then you have salting here, random salt per password. Okay, so if you are doing it random salt means, so if you are generating one password with the one password hash, you will get one value for one password. Okay, so rainbow tables are so this also we have seen that rainbow tables, where you will have bunch of tables where you can put that and you can attack it. Okay, so I will open up that again. I will show you where that rainbow tables will be. Okay, so this is the rainbow table crack here. Okay, let me open this. So these are all the pre-computed rainbow tables here. You can download it and you can use it for cracking here. Okay, most of the hackers will have their downloaded copy. Okay, and then they will start attacking it. Okay, so there is downloaded, okay, rainbow table. So this is how your passwords will be cracked here. Okay. You are not going to use MD5 hash, okay, or SHA-1 hash, okay, because nowadays you have GPU which will crack 100 billions per MD5, okay, so it will easily cracked. Okay? If you are using it, then it will be cracked. So that is why we will not be using the MD5 or SHA-1 for hashing. Okay. So then we will be using this bcrypt blowfish based password hashing. Okay. So where you will have like this will be your password hash. Okay. So which will be incremental here. Okay. It will take defaults. It will take. Okay, so using this your password length limits will go to 72 bytes. Okay. Input you can go to, and it can be longer than 72 bytes here. Okay. So you cannot put more length for that password. Okay. So this is the 60 character length. So whenever you do a blowfish password hashing, so this password will be connected, will be converted like this. So this is your bcrypt. So then here script is the memory hard password hashing. Okay. This is one more algorithm where you will be using this password hashing method. So one, you will be using CPU memory cost. Okay. So then your R block size. and then the parallelism here. Okay, so that is how you will be calculating this memory password hashing here. So then you have argon 2. Okay, so which is your GPU resistant here. Okay, whenever you do some password hashing, you cannot do it with GPU resistant. Okay, so argon 2I also, these are all algorithms, you don't have to remember all this. This is how you will be using it for storing the password or changing the password into a different salt. Okay, so then you have something called argon 2. Okay, where you will have a parameter which is the OWA SAP recommendation here. So this is how you will be using for doing the hashing here. Okay. So this is one more PBK DF2. So this is also password based key derivation function. Okay, so these are all the standards that are approved here, but whenever you use a high end GPU, this will be cracked easily. Okay, so you don't have a memory cost here. So if we are doing it with these passwords, with this encryption, it will be cracked easily. Okay, so then you have here algorithm comparison here, which one will work for what algorithm. So these are all the modern password hashing. Okay, bcrypt is moderate on GPU resistant. Okay, if we are using GPU to crack it, so it will be very low here, GPU resistant. Okay, so we will be using based on the requirement, you will be using this password hashing. So then you have end-to-end encryption overview.
So how will you be able to get to know that when you are the password, but whether is it at a low rate, a medium rate, or a high rate passwords?
So these are the encryption, it will automatically convert, okay, based on the standard here. Okay, so if your iteration default, what is the cost, what is the length, all you will consider here. Okay, so if you are using this, it will be memory hard. Okay, this is no. Okay, you don't have to get memory here, much of the memory. So here it will be memory, you need to be using this memory hard. Okay, so if you are using GPUs, okay, let's say if you are using GPUs, then it will crack it easily. Okay, so that is how it will be done here. So based on the algorithm, based on your requirement. So now it is FIPS approved. So this is the standard. Okay, only this is your standard. So these are all not approved. Okay, so based on this, you will be going ahead with that. Okay, so OWASP recommended, these are all recommended. This is the legacy, means very old. This will be the first choice, argon 2 ID. Okay, so then you have end-to-end encryption. Okay, so there will be communication between read messages, no third party message. Okay, not even the service provider. Okay, just like the WhatsApp is also end-to-end encryption. Okay, even WhatsApp will not be able to see that. Okay, so now we have a signal protocol. Okay, where we will be using the signals uh, and you will be encrypting that signals. Okay, so this is all advanced topics used by Signal. Okay, WhatsApp, Facebook Messenger, Google Messages. Okay, so they will be using this double ratchet algorithm. Okay, so once you send the message, nobody will see. That is the whole idea of using these protocols. Okay, so how you are using this? Okay, so what type of protocols you are using it, end to end implementation in messaging. So Signal, okay, this is a messaging application where the algorithm you are using is X3DH plus double ratchet. Okay, so the encryption is very strong here, end to end, nobody can see that. So WhatsApp will also use the same Signal protocol only, end to end. Not even WhatsApp will see the messages. Okay, so then you have iMessage, you have Telegram here. Telegram will be using the algorithm, different standards here, MT Proto 2.0, then protocol OLM. So all these are used by this. Okay, so this is self-hosted. Okay, so this is used by Meta here. Okay, so backup may be unencrypted, means, so if you are taking backup of the messages, then it will be visible. So that is what these are all. Okay, wire is based on the European Union standards here, which will be with the GDPR standard. Okay, then you have challenges here. Okay, let's say if you have logged into multiple devices, you have logged into WhatsApp, and then you have logged in from the mobile, then you have logged in from the portal, means web.whatsapp.com on your Linux or your Windows. So you need to have a session for every device. Okay, adding a new device, you need to have a rekeying. Okay, and trust verification. Okay, so you cannot have access to both at a time. So only once you can access it. If you open it in web, you cannot access it in mobile. If you open it in mobile, you cannot access it in web. Okay, so multi-sync, multi-device sync, it will allow only one, so that all this can have a end-to-end session. So if you are doing multi-session, then there will be a problem here. Okay, so now you have backup security. So all your WhatsApp messages goes to the Google Drive or your iCloud. Okay, so which is not a end-to-end encryption. Okay, so backup will break this end-to-end encryption, which will not guarantee if it is not encrypted. So then you will have group messages which will be paid, okay, in large groups. Okay, so then you will have key verification. So whenever you open WhatsApp, it will be sending, okay, the key has changed, someone's fingerprint has changed. Okay, this will keep on verifying whether the other person is connected or not. So they will be verifying that. So then we have challenges here. Okay, who is going to talk when they are talking, what is the frequency, all that. Okay. So signal protocol will minimizes all this. Okay. And the other protocols will not do this. Okay. So with respect to endpoint security means your end device. Okay, your end device, it will be secured. All your mobile devices will be secured there. Okay. So now we have VPN protocols. Okay, VPN protocols is like, so you have client device here, then you have VPN server, then the internet destination here. Okay. So let's say if Indian government blocks any website, you will just connect it to a VPN server. Once you connect to a VPN server, the traffic will go in encrypted tunnel, then it will pass to the plain traffic. Okay, from here you will be accessing it. Then you have remote access, and then site to site, privacy, and zero trust VPN. So these are all the different mechanisms that we will be using for connectivity. Okay. Okay. Bhargavi,